Hi there, my name's Terry Brown. I'm the subject coordinator for 41054 Applied Mechanics and Design A. And in this little video, I'm just going to go through a quick subject introduction and overview. You can see some pictures on the screen there that give you some idea of the kinds of things that we're going to look at. So firstly, just give you some background on me and how I've used this subject's content in the past. So one of the ways that I've used it is with the Formula SAE UTS Motorsports team in designing the vehicle components. In this particular example, we're looking at the wheel, upright, spindle, and other suspension components here. So you can see here I've done some free body diagrams. So as you'll hear over and over again in this subject, the importance of drawing free body diagrams. And you can see here that I not just say to do these things, I do them myself. Okay. Use drawing instruments, not everywhere, but you can still see clearly where all the forces are going. All right, so then from there, we can also look at here, I'm just showing an example of 3 force members and 2 force members, something else that you'll learn about in order to work out what the reaction forces are. And then from here we go, so we probably won't be, well, definitely won't be assessed. Use of simulation tools. I'll use them and show you them in context, and you may, or it could be assessed if you want to do it as an optional thing for your project to get higher grades in the subject. But yeah, so making use of these calculations that I've done here to work out what loads we need to put on to the finite element model. I've also done something completely different in terms of context. So this is looking at biomechanics and hip implants. So looking at prostheses and bone implants. So again, you can see making use of the fundamental engineering mechanics in order to understand what's going on in terms of the forces and loads that are being generated throughout the structural components. And then going and calculating stresses, looking at the internal actions, so internal bending moments, internal normal forces, shear forces, and so on. So these are all things that you're going to hear about throughout this subject. Now, it's only because I have a good understanding of these fundamentals that I'm able to interpret correctly my finite element models. If I go back here, the first time I did this, the results that I got, I could clearly see were incorrect. Right? So, and it was because I understand what should be there, not exactly what the number will be, right? Otherwise there's no point doing the analysis, but having a feel and an understanding for what the order of magnitude of those stresses should be and how the stresses should be distributed in this particular component enables me to properly do these simulations. Right? And that's what I'm hoping for you for this subject, is to be able to understand really what you're doing. Let's get into some words without pictures. So what's it all about? So the subject learning objectives are that you should be able to design simple machine structural components for strength and stiffness. And those are different things, okay? Often people confuse strength and stiffness and think that they're interchangeable terms. They're related, but they're not the same. To be able to analyze simple machine structural components by making use of the fundamental engineering mechanics, such as I've just shown you in the examples where I've done some work. Apply some experimental and computational techniques. So at a pass level, you may not necessarily do this. At a high distinction level, then you may do this as an option. Also referring to relevant design standards to meet minimum safety requirements. Okay, so again, not part of the passing requirements, but you may make use of this in getting a higher grade. Course intended learning outcomes, or the UTS graduate attributes. So hopefully you've heard about these before. If not, just do a Google search, UTS graduate attributes, to see all 6 of them. This subject primarily focuses on 2 of them. I guess firstly being technically proficient, and then secondly design oriented, and then possibly socially responsible. And this socially responsible comes in with designing according to standards. And then we also, as engineers, we need to meet the Engineers Australia Stage 1 competencies. And we've only got really two that we want to focus on in this subject. And they are the comprehensive theory-based understanding of the natural and physical sciences and the engineering fundamentals that apply to what we're trying to do. And then fluent application of the engineering techniques and tools and resources that we have available to us. So that's what we're trying to develop in you through this subject. How will this subject content be used in future subjects and in industry? So firstly, think about future subjects. What I've got here is a picture from a student's report from one of the design studios, so the mechanical design studios that are coming up. You may be doing it in parallel with this subject. You may even be doing it, may have done it before this subject. But hopefully you're doing it after you've done this subject, so that when you get to something like this, you can do a much better job of analysing and designing these components than what this student has done down here. Okay, so that was it in terms of their analysis. So hopefully you look at that and think, well, that's hardly an analysis and design, and that's good, because it's not, right? And even what they say down here is incorrect. So if you really engage in this subject, take the opportunity to learn from myself and your tutors and from the materials that we have available for you on Canvas. You'll quickly see that these two components here are probably the least likely to break. Well, maybe not the least likely, but certainly less likely than this one, right? Because this one is in tension and compression only, whereas this one's in bending, right? So they talk about bending and they look at this member here. Well, this member's not going to be in bending, right? So hopefully when we look at 2 and 3/4 members and frames and machines problems, so in weeks 3 and 4, you'll be able to look at this and say, I know how to analyse this properly. Right? You should be able to analyse this. Looking at some Australian standards, so this is the Australian standard for design of rotating steel shafts. Here's a typical mechanical device. So some kind of a conveyor drive. You've got some motors here, you've got a shaft here, you've got some gearboxes. And in order to analyse and design this and to apply the Australian standards, you need to draw your free body diagrams, you need to apply your equations of equilibrium, you need to draw shear force and bending moment diagrams. Here we've just got the bending moment diagram in 2 planes. Okay, so these are things that we'll be doing. All right, we probably won't, well, most of you, if you're just going for pass level, won't have to do directly related to Australian standards, but I'll put in some examples as along the way as we go. Right? But if you do a higher level project or problem, then you could do this as an option if you wanted to. Ladders. Okay, so here's an Australian standard for design and analysing ladders. So here's some of the experimental testing that you need to do to validate your design. What about jobs? Okay, so firstly, what is mechanical engineering? So mechanical engineers do a whole range of things. It's one of the most diverse of the engineering disciplines. I would say the most diverse, because you can be working in all sorts of fields and doing all sorts of things. So it goes from manufacturing to mining to fluids to power generation to product design, automotive design, vibration and acoustics, and so on. Okay, so but as it relates to this subject, you can see here, requires a deep understanding of the core concepts of mechanics. So that's what we hope to give you in this subject, material science, and we use these along with computer-aided design tools. Okay, a lot of students want to bypass this bit, right? But you can't. You need to have a good fundamental understanding of the core concepts in order to properly use the computer-aided design tools such as finite element analysis. Biomedical engineering. So you already saw the example of the work that I've done in biomechanics. So here I've just highlighted design equipment and devices, use their engineering knowledge, what qualifications are required to be a biomedical engineer, some mechanical engineering, understanding, physics, and so on. What about mechatronics engineers? Again, we can see here, so this is taken from SEEK, designing, testing and manufacturing machines, systems, mechanical systems, design or developing solutions to problems with mechanical processes, conducting modelling, simulation and analysis of engineering systems. And you can see the classic diagram here for mechatronics. You've probably seen it's the overlap of all of these things. And what we will be focusing on in this subject, of course, is the mechanical systems that you need in order to fill in this part of your knowledge to be a mechatronics engineer. Okay, so, and just fitting it into the typical mechanical engineering curriculum. All right, so these are the topics of this subject. So machine components, statics and forces, materials and stresses. So they're all, whoops, wrong way. They're all part of mechanical systems, which is part of engineering science and analysis. Then we also, in this subject, look at technical problem solving, communication skills. So when you present your solutions, I ask you to present them neatly and clearly and in a professional manner. Okay, because that all contributes to your professional practice. These lead into innovation and design, knowledge and skills, right, which interacts with your fundamental understanding of the engineering sciences and analysis. All right, so that's a longer introduction than I wanted it to be, but hopefully that gives you a good overview of this subject and what you're in for. All right, so I'll see you in class.